Hello, folks. I hope everybody's doing okay and that you are enjoying somewhat more spring-like weather here. The good news now is that we are getting on toward the end of the school year. We actually have just 3 weeks to go, including this week, and so not a whole lot more stuff to do. Last week, one of the things we did was reviewing the distance formula, where you could find the distance between 2 points. And we also had a quick introduction to what were called conic sections. Those were shapes that you could get by slicing a cone in different directions: a circle, a parabola, an ellipse, and a hyperbola. And we mentioned those could also be defined using distance. I didn't really say anything more about it at that point, but it was one of the different ways that you could define conic sections. Now, you guys have already talked about parabolas, so that, in a sense, is old news. We've done parabolas. The screenshot you have at the top there is literally from a worksheet that you guys did back earlier in the year. So we're not really going to talk about parabolas this week, but with 3 weeks to go, what we're basically going to do is spend 1 week on each of the other conic sections, on circles, ellipses, and hyperbolas. We'll learn how those work and hopefully have a good introduction to those different shapes. So what we're going to be learning about this week is circles. And I know we've got a handful of people in advanced algebra that are also taking geometry. And those guys actually did a lot of work with circles the past couple of weeks. The rest of you actually did what they're doing now a year ago, and so some of what we're going to work with circles is review. You should remember that a circle is just all the points in a plane that are the same distance from a fixed point. The fixed point is the center of the circle, and the radius is that distance. The idea is that you could find all the points all the way around that you measure the radius out to, and what you end up with is a circle. The single most important word in that definition is distance. And that's why last week we spent some time learning about the distance formula and how you find the distance between 2 points, because distance is what we're going to use to figure out how we work with equations of circles. The big thing you want to become familiar with this week is what we call the standard equation of a circle. And it's given to you there. It says x minus h squared plus y minus k squared equals r squared. We're going to look at a bunch of examples in this video. You're going to do some problems, and of course when you get to a quiz, you're going to need to apply that formula. And by the time we're done, you should kind of know it in your sleep. X minus h squared plus y minus k squared equals r squared. That formula really is just a fancy way of talking about the distance formula, because the idea is that if I have a point on the circle, xy, and I have the center of the circle, hk, if I wanted to find the distance between those 2 points, I basically work out the Pythagorean theorem, and I'd find that r, the radius, would just be the square root of x minus h squared plus y minus k squared. You square both sides, you get exactly what the circle formula says. The important thing about that formula is that the point hk is the center of the circle. Now, if you look at the formula, it says x minus h and y minus k, and because of that, the formula always has opposite signs from what's at the center. At the end, it says r squared, and it should kind of make sense that r is the radius. The x and y, from your point of view, they're just the variables x and y, but they stand for any point that's on the circle at all. So again, that formula, x minus h squared plus y minus k squared equals r squared. Hk is the center, r is the radius, and x and y just means some point on the circle. So a real typical kind of question would look like this. What is the equation of a circle with a center at 5, -1 and a radius of 7? If you think about that for a second, and you think about the formula we just said, all we're really doing is plugging numbers into the appropriate places in that formula. It's going to be x minus 5 squared plus y plus 1 squared equals 49. The two things to keep straight about that is that you always do the opposite sign of that point that's at the center. That's why I've got minus 5 and plus 1. And at the end, it's always r squared. 7 squared is 49. So again, x minus 5 squared plus y plus 1 squared equals 49. So here's 3 more questions. We'll see if you can figure these out. We have the center at 9, 2 and a radius of 4. Center at the origin and a radius of 1. Center at -3, -13, and radius 11. You might want to pause the video for a second and just see if you can come up with those 3 answers. And again, you always want to do the opposites of the center and then square the radius. That's why the first one's going to be x minus 9 squared plus y minus 2 squared equals 16. On the second one, remember the origin is just 0, 0. I wrote this as x squared plus y squared equals 1, which those of you that go on to analysis next year will find out is the single most important circle there is. You could also just write it as like x minus 0 squared plus y minus 0 squared equals 1 as well. And the last one's going to be x plus 3 squared plus y plus 13 squared equals 11 squared, which is 121. Another question here. This time I'm giving you the equation. You need to figure out the center and radius, and the equation is x minus 2 squared plus y plus 7 squared equals 9. And again, I just remembered the center's got to be the opposite, and at the end of the equation it says r squared. That's how I know the center has to be 2, -7. And since r squared is 9, we got to do the square root of 9, and that means my radius is 3. So think about this one for a second and see if you can figure out the center and radius of x plus 8 squared plus y squared equals 100. And this time our center is going to end up being at -8, 0. And for the radius, I've got to do the square root of 100, so it would be 10. Here's another kind of question. This time I've got a graph of a circle. And the question is, what's the equation of this circle? So look at that a minute, see if you can figure out what do you have to do to figure out what's going to be the equation of this circle. Well, the first step is going to be to figure out what's the center and what's the radius. So I actually highlighted where those would be, and it makes it a little bit easier to see. The center in this circle is going to be at the point -5, -3, 5 to the left and 3 down from the origin, and the radius is 2. So if you go back to that same formula, our answer is going to end up being x plus 5 squared plus y plus 3 squared equals 4. And here's another question. We have the center of a circle is at the point 4, -7, and the point 9, 5 is on the circle. Find the equation of the circle. You need to look at that for a second and think, what's missing? What haven't we given you to do this problem? And before you do anything else, what you're going to have to do is figure out what's the radius. That we don't know ahead of time. We do, of course, know the center and a point on the circle, but you got to know the radius to fill in that equation. The radius is just the distance from the center to the edge, and that's why all I need to do to find the radius is use the distance formula. It's basically a problem like what you had last week, where I just plug in the points, subtract them, take the square root, and it turns out this time that the radius has to be 13. Once I know that the radius is 13, I can go back to my standard formula. I put in the center, and it is important that it's the center you use, not the other point. And my final answer is going to be x minus 4 squared plus y plus 7 squared equals, and of course 13 squared is 169. Here's one last example we're going to take a look at today. It says the points 5, 3 and 5, 11 are at opposite ends of the diameter of a circle. What's the equation of the circle? Again, you might want to pause things for a second and see if you can figure out what's up with that one. Well, in order to find the equation of a circle, what I've got to know is the center and the radius, and technically I don't know either of those things ahead of time, but I can figure out both of those. So I've got to figure out what's the center and what's the radius. So the center is exactly halfway between the ends of the diameter. And what I'm technically doing is finding the midpoint of those 2 points. Basically, I'm averaging them. And since the 5 is the first number in both points, it's going to be the x for my answer as well. What I do for the y is I just literally add up 3 and 11, 14, divide by 2, and it turns out it's got to be 7. So yes, 7 is halfway between 3 and 11, and my center's at 5, 7. Once I know the center, I could use the distance formula to figure out what the radius is. I can also think, gee, to get from 7 to 11, I've got 8, 9, 10, 11, that's 4 more, and so the radius must be 4. So our center was at 5, 7, our radius was 4, and that means the equation's got to be x minus 5 squared plus y minus 7 squared equals 16. So that's pretty much what we got this week. You're going to have some problems that you will be working out the circle formula, and of course there's a quiz where you'll be dealing with that as well. Next week we're going to learn about ellipses, and the last week we'll be taking a look at how hyperbolas work. So that's the basics of where we're going the rest of the year. Hope everybody's doing okay, and we will call it good for this week and wish you guys well.